From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
MPDS are these material allowables for metals. It was the former Milham Book 5, and we need that because everything in aviation is empirical. It's all based on test data. And once you have those test data, you can use the material allowables to create your design allowables, which have your margins of safety and those are your engineering calculations.
That was Bill Bihlman. Bill's the founder of Aerolytics. The company's focus is to improve market share and revenue for aerospace suppliers, from mills and forgers to fabricators, assemblers, and distributors. Bill started his career in 1995 as an engineer with Raytheon Aircraft. More recently, Bill was a senior consultant with AeroStrategy. There, he spent 4 years working on the U.S. office and was actively involved in over 30 projects. He led multiple engagements and was responsible for two major intellectual property initiatives, including the Aerospace Raw Materials model. Bill's a regular conference speaker and has spoken throughout North America, Europe, Asia, and the Middle East. Topics include raw materials, manufacturing, and supply chain. He holds a BS and MS in mechanical engineering and a PhD in industrial engineering from Purdue University, as well as an MBA and MPA from Cornell University. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. All right, Bill, thank you so much for joining the show today. I'm excited for the conversation. I think there's going to be a lot of stuff that we can talk about. But like I do with all my guests, I think the place I always like to start is kind of starting way at the beginning, kind of where you're from, where you grew up, kind of what got you into the engineering kind of realm.
Well, first and foremost, Mike, thank you for the opportunity to be here. This is a first for me. I haven't been on any podcasts, so I hope I don't make too many blunders along the way. I'm excited about this opportunity to talk a little bit about additive and my background in particular. From Indiana, from Bloomington, kind of defied all odds and went to Purdue. It's Indiana University territory. And studied engineering. I've always had a passion for aviation. And when I came here, naively, I thought I was going to be an aerospace engineer and double major in aviation. That didn't happen. I ended up studying mechanical engineering, and I did fly on the side. And then my first job, stayed for my master's, and then went off to my first job, which is a bit of a dream job at Beech Aircraft back in the early, mid 90s now. So it's been a few years and worked there for a number of years. And it was wonderful. And then they sent me off to business school, and it's kind of I was corrupted because you started talking about money. so kind of a little different path, but I've been passionate about aviation ever since.
And so was that always the spark in terms of kind of when you were growing up, kind of aviation, kind of airplanes, and kind of push you to kind of engineering, or did you like work with your hands and projects? What kind of got you started?
Yeah, well, I guess I was like any other kid where I liked to build things when I was younger. I loved models. I was always fascinated by aviation. I still am. I'm like a kid. I live now in Lafayette, Indiana, back here at Purdue. I've moved around a few times, but I'll still run to the window and watch the planes come over because I'm on final for the Purdue airport. So it's just something that I've been captivated with. So I think that was the natural extension. I don't know how much guidance you had when you went off to study material science, correct?
That's right.
But I went to my high school counselor and talked about different career options, and he said, well, you're strong in math and science, you should consider engineering. So that was kind of my introduction. I didn't see the natural fit, and I didn't have anybody in my family, or immediate family at least, that was an engineer to be a model. So it was a bit of an experiment when I came here, but it seemed to be a good fit. I don't work in my capacity now as an engineer, and I haven't really since I went back to school in 2000, back to business school. But I used that kind of that insight and that technical training for decision making in many different aspects, probably like you as well. There could be some similarities here.
And what was you were at Beech Aircraft, did that, and then kind of the MBA, but when did you start kind of getting interested or involved with the additive manufacturing world?
Well, so this is kind of beer conversation, Mike. So, a bit of a circuitous path. So after business school, I studied public policy and then went down to South America to work. I wanted to take a little bit of a reprieve from aviation, especially because living in Wichita, Kansas, there were kind of the ebb and flow of the market. And so you could really feel the differences, the fundamental changes. And I also wanted to do something that I felt I was giving a little bit more back to the community. So I spent some time, I wrote a thesis on trade and development and spent some time in South America. I was in Uruguay and then came back to a sick mother. And this was back mid 2007. And that was pivotal for many, many reasons on a personal, but also professional level, because that's when I got involved in management consulting. So I worked for a gentleman in Ann Arbor, Michigan, Kevin Michaels, and Kevin was kind of a consummate management consultant. A lot of engineers turned MBAs, and we started working in materials and not less manufacturing, but materials and a bill of materials. So you understand what materials are being consumed when you build an aircraft. So that was kind of my first introduction, or more of a closer look at materials. And then my mom got sick again in 2011, and that's when I decided to step away and do a few things on a personal level, spend more time with her. And then I started to get more involved in manufacturing, because that was a natural extension for materials. And shortly thereafter, and I don't know exactly what the catalyst was, but I was introduced to additive, and it was probably around 2013, just hearing about the technology that you can print just about anything. Complexity is free. And I've been kind of studying it ever since.
That's awesome. And so what sort of work do you kind of do as it relates to additive? It sounds like kind of a lot of the business, the materials kind of all mixed together. How would you describe it?
Yeah, well, so I started my consultancy in 2011, and the company is Aerolytics. And there's basically three focuses. One is the material space, the other is the manufacturing, and the third is supply chain. Because if you understand the supply chain, and that's really the execution of the materials and the manufacturing. So those are the three areas that I focus on. And I ended up going back, like you, I went back for my PhD, but much later in life. I started down at Texas Tech and then transferred to Purdue and kind of started all over again, to be honest. Studied this time industrial engineering, because I see it as the nexus between upstream, the design of aerospace, mechanical and electrical engineering, for example, and then the downstream, which is the technology, the implementation, the technicians, and then way downstream, just business, just the money aspects. So that kind of overlap in the center I see is industrial engineering and the applied nature of how do you build it? What's the feasibility? What's your return? How can you scale your operation? So I've been working on that in industrial engineering capacity and kind of a quasi capacity now since I graduated last year, but even before that. So I kind of combined, I'm also interested in policy. So I kind of combine those elements of trying to use technology as the impetus with the business case that's supporting that, because everything comes back to kind of what's your return on investment? How do you justify this type of investment? And then gauging risk, of course, and then policy supports that, especially for aerospace, because we're so risk adverse. We really adhere to kind of a whole litany of policy constraints and guidelines.
The additive industry is interesting in that sense, where you can kind of do all of that in a new way, right? Because it's all developing as we go. Like there's new machines, new materials that make new implications for companies to say, hey, does it make more sense to build stuff in the US because this manufacturing method is already more expensive? We need higher skilled people in some cases to do it. And you have sustainability and design. So like, it seems like you're a kid in the candy store. That's what I kind of feel like. Yeah. It's like, there's so many different problems, whether it's technical problems, people problems, organization problems that can be addressed in the context of additive.
Yeah, no, I completely agree. I think it's, with opportunity, there's challenge and vice versa. So I also support, and I think we've talked about this before, you're familiar with my work with SAE International.
Mhm.
It's funny because when I had an opportunity to support David Alexander, who's the head of all of aerospace standards for SAE,
And so just so everyone knows, SAE is a standards organization that stands for...
Well, it stands for Society of Automotive Engineers, but
Okay.
they've been in aerospace since the 30s. Actually, they released the first, it's called AMS, which is kind of the gold standard for materials in aerospace materials specification. Their first AMS spec was back in 1939. It was obviously for aluminum. So they've been in that space of working predominantly with metals since the 30s. And there was a group that was set up in 2015 by a tasking letter by the FAA to say, hey, we need some guidelines for the reasons that you just mentioned. There's so much green space here in additive. We need to put in place first, let's say, best practices, and the next standards. So we all have common language, and we're not the only, it's called SDO, Standards Developed Organization. SAE is not the only SDO that works in this space. There's other engineering organizations here in the US as well as internationally that are trying to coordinate these. And now the goal and the challenge becomes to harmonize these. Because if there's conflicting standards, then that really creates issues. But to the point that you just made, it's almost endless flexibility, which in aerospace is kind of overwhelming, because when I speak at these conferences, people embrace additive because you can basically build anything. That's not entirely true. You and I know that, but let's say you can build a lot of things. The ship in the bottle, because you're building things by layer, and really the business case and the impetus in aviation is to lightweight an artifact, an article, whether it's a gas turbine blade or something in the aircraft, some structure. But what we don't know when we create that form, fit, and function, we have something that looks like a useful artifact, but we don't necessarily know the integrity of that part. And so that's what those standards allow, is to help minimize the uncertainty in building something, because in many cases we're doing this for the first time because the parameter sets are so vast. So.
And where do you, I mean, it's not just your decision, but I mean, you're kind of at the table for a lot of the SCA discussions. Like, where do you even start? Like, there's metals, there's polymers, there's different processes. Like, how do you even think about starting that problem of standardization?
Well, I think that the first thing that you do is you convene people who would be considered experts. We'll call them SMEs, subject matter experts. So you bring them into the room, and then you decide based on consensus. And you probably know the kind of the life cycle of a group, where you probably heard it: forming, storming, norming, and performing. So that's kind of what we've gone through. I wasn't part of the genesis back in 2015. Dave Abbott from GE was, Hector Sandoval was, who's at Lockheed Martin. Holly, Holly Dushman quite well. She's now at Siemens. But those were some of the original parties at the table, and they've stayed the course and continue to be involved. But it's having that type of constructive dialogue, and I think that's the beauty of an effective organization, is to provide the catalyst to move forward in a general direction. But what's interesting is the organization, and this is probably a sign of effective leadership, it delegates, right? And then you step back, and these empowered groups, now we're north of 550 members, 220 different organizations, and it's global representation of not only companies, but also the supply chain, in terms of the different types of companies that are involved, all dedicated to aerospace in this. And you start with a consensus and identify what the problems are. So the first framework that we developed, it's the 7000 series, called AMS 7000. We have 4 specifications that we put together, and it happened to be for Inconel. Let's just generically call it Inconel, if you would, 625. Or some people call it Alloy 625. So we developed these specifications around that. And with that, you need to build an aerospace part. You need first a material that's you can count on, right? It's in the regulations. It adheres to 603, which is part of the certification guidelines. 605 talks about a controlled process, and then 613 of the regulations, whether it's Part 23, Part 25, Part 27, it talks about these test coupons, because everything is empirically based for aviation. So you develop these test coupons. Let's say you look at the tensile strength of these. You consolidate this data, and then you provide material design allowables that you use in the aircraft. So we started with metal, because metal is kind of the ultimate objective, but we also work in polymers as well, and we work closely with the National Institute for Aviation Research, NIAR, and they have an organization called NCAMP, the National Center for Advanced Material Performance. And they were working closely with Stratasys and the FAA to qualify the Fordham 900 and the Ultim 9085 project. So now we have a thermoplastic that we can use, flame retardant. So it's used extensively for repairs in the interior. So those were two of the main projects. And kind of with those frameworks, then we've developed other materials and commodities. But it's a challenge trying to arrive at that consensus with regards to where to start, to your point, and where do we go next. And that's one of the challenges that we're grappling with at the moment.
And over the time that you've been in the additive space, maybe specific to aerospace, like what have you seen kind of change or develop? I mean, you were at Formnext a couple of weeks ago, and so like the technology's always changing, but like what are there any just general trends that you're seeing maybe from the adoption side, the business side of additive? Is it getting out to more suppliers, or what are you really seeing?
Well, I think that the emphasis, and I can only speak from an aerospace perspective, the emphasis is still on metals predominantly. Not to say that plastics aren't important, or polymers. In the polymer space, we've got kind of it's not a newcomer now, but a newcomer in terms of the qualification process going through the equivalent. So MMPDS are these material allowables for metals. It was the former Mill Handbook 5. And we need that because everything in aviation is empirical. It's all based on test data. And once you have those test data, you can use the material allowables to create your design allowables, which have your margins of safety, and those are your engineering calculations. So we do that both for metals as well as non-metals or polymers. The counterpart from MMPDS is CMH17. So we're working with those organizations. We have somebody now sponsoring in the non-metals group through SAE-AMS, Mark Forge, and looking at continuous fiber. I think that's really exciting. Now, granted, you can't make particularly large parts, but now you can make structural parts because the carbon fiber is what carries the load in these polymer parts. So that's pretty fascinating. I don't know, when I was at Formnext, if there are many competitors in that space. I think Mark Forge is pretty well positioned. But eventually there will be competition. And we talked about this earlier. You were in Formnext back in 2019. The landscape changes quickly, and it's usually like, maybe it's like the grocery store, right? All the fresh food is on the outside. And here those are the young companies. You go around the perimeter, and they're the smaller kiosks and pavilions, and you see a lot of innovation there. The more established companies are usually front and center. So on the metal space, the emphasis, it's still a crowded territory. I predict that there will be consolidation and eventually bankruptcy, but you've got 6 or 7 companies from the best known, EOS and Renishaw, SLM, and Concept Laser, now part of GE Additive, but all the way down to companies that aren't as well established, like Trump, a German laser company, and even companies that were in metrology that are looking at this. And now I think one of the paradigms, I don't know if it's a fundamental shift yet, but the direction we're heading are for low cost machines. So a typical machine for, let's say, a laser powder bed fusion system is on the order of $400,000. There's Exact Metal is a company relatively new out of Pennsylvania that is a machine that's under 100,000. As a matter of fact, they just reduced the price to 65,000. So that can be really disruptive. That's on the machine side. On the powder side, I think there's a lot of innovation, and here you're the expert now in terms of the material scientists being able to experiment with smaller batches. I think that's the lure, and to a certain extent with additive manufacturing, you don't need an entire heat of material to pour your castings and then do experiments. You can do these on much smaller scales and now start mixing these materials. So again, that same type of design flexibility is offered in terms of materials development, especially when you couple that with analysis, ICME, integrated computational materials engineering, and look at trying to predict performance based on chemistry and so forth. That's fascinating. But in aerospace, there's really not a lot of innovation. We still look at the predominant commodities. I think AMS is an excellent example of what we're targeting and why, but we're still looking at titanium, 6.4 or 6242 or 5553, looking at stainless steels, 15.5, 17.4, aluminum super alloys. I mentioned Econel 625, but also 718 and Wasploy, Hasploy, and so forth. So that's where the focus has been, even though there is innovation, I would argue, outside of aerospace for metals, metallurgy, and not just powders. We look at wire too, but 95% of our specifications are written for powder, which is a much more volatile material, as you know.
Right. And so shifting gears a little bit, I always like to ask folks, I mean, even similar, you're kind of on a similar path as me in terms of kind of the consulting path. So what is it like kind of giving people, one of the goals of this podcast is to kind of give a glimpse into a day in the life of folks that are working in the additive space. And so kind of from your perspective, what do you like about kind of your job and kind of what you do, and kind of, can you give kind of a general description of kind of the day-to-day details of running your business?
Well, that's a great question. How about if we just start with, do I like what I do?
Sure.
And the answer is yes. Do I like it every day of the week? Clearly, no. I mean, who does? But the things I like about my job, I'm very independent. So I like the flexibility. It's a bit of a crass notion, but there's this whole idea when you run your own company, you eat what you kill. I don't know if you've heard that that phrase before, but there's some truth to that. And for the right personality, it's liberating, because you feel this great sense of when you win a major project. But I would say that being an entrepreneur, I've actually had this debate recently with a colleague who says entrepreneurs are extremely risk adverse. I couldn't disagree more. I think it depends on how risk seeking, but in general, I think the average entrepreneur leans into something. And it really, I think that's what it begins with. It starts with your appetite for risk and dealing with uncertainty, right? Which is synonymous. But I think financially, if you're in a position where you have some flexibility, because I think that could be the ultimate constraint, or if you have, I don't have any dependents. So if you have a family where you can't necessarily go a couple months without a paycheck for whatever reasons, then I think it could be a very, very difficult road. But what I like is, again, the flexibility and the opportunity to travel. I like meeting new people. I like, I guess, atypical of an engineer. I've got a relatively short attention span. I like a dynamic environment, and I like change. I've moved a lot in my lifetime, and I like that. I like that aspect of management consulting, that the project durations are short. They're in the matter of months. The downside is that you don't necessarily get closure so you work on an engagement, and our final products are reports. We call them decks. So we provide the deck to the client, and those are a series of recommendations. It's not as structured, let's say, as a scientific analysis and definition of the problem statement, but there's a methodical walkthrough of identifying the problem and then a framework to solve the problem and answer the client's question or questions. And sometimes it's anticlimactic, because you don't necessarily know after you make these recommendations. Number one, if they did it. Number two, if they did it well, and it was successful. So from that standpoint, I enjoyed the project engineering when I was back at Raytheon Aircraft towards the end of my tenure there. you could walk the floor and see aircraft, and the whole idea of kick the tires. There was a tangible product. So offering a service is a bit different. And I think you're somewhere in the middle, because you work in the software industry. So you have a tangible product, but it's not necessarily making something like a Tesla automobile.
So kind of last question of the day, what are you looking forward to in 2022? I have to think for a second there, but I mean, from a new technology standpoint, or from the work you're doing, your projects, is there anything that's kind of exciting from your perspective?
Well, on a personal level, there could be a major change, and that's probably, I don't know if I want to make that public yet until I really know for sure if that's going to happen. So that's kind of it's exciting as it is daunting, but kind of looking to make a few changes. After coming back to school, I moved back to Lafayette, as I mentioned earlier in the podcast, and so I'm maybe looking to make a change there. In terms of the technology, I don't know if there's anything that's kind of on the precipice of materializing. I think that working with standards is interesting, because originally I was a bit remiss to get involved, because it seemed like it's glacial. It's like, it's too slow moving. Well, the average standard takes a couple of years to release, because it's heavily vetted, and you have multiple perspectives, but by the time it's out, and the art of writing a standard is sufficiently vague, it's Goldilocks, right? It's that not too hot, not too cold. So really trying to right size that so it's effective, it provides enough prescription to give guidance, versus being overly prescribed such that it drives cost up unnecessarily, and requirements that just don't add value to the final product. So from an SAE standpoint, we're looking at trying to take these standards now. We have over 25 that have been released and another 35 in development, and now trying to implement these to help the industrialization process. And so we're going through in some strategic planning, where we're looking at moving beyond material and process, that controlled process that we talked about earlier, and looking at trying to enable the supply chain a little bit more. But of all industries, aerospace got hit pretty hard, probably not as hard as the restaurant industry and travel and tourism, but in general, many of the OEMs have had a really, really rough year this past year and a half. And so I think that there's glimmers of hope and light. I think nobody really knows. Nobody, of course, has that crystal ball to see if the economy is really going to pull up and pick up, and we're going to go back to life as normal. It'll probably be another year, I think, before that really happens for aerospace. And I think beyond additive, I also work with thermoplastics and thermal sets, and there's a lot of energy in that space, and that's kind of adjacent to our conversation at hand. But advanced air mobility, they're spending billions and actually hundreds of billions of dollars globally in this market. There's a role for 3D printed parts, but right now, using kind of the analogy of crawl, walk, run, we're still in that crawl space, because we're trying to figure out the configurations of these aircraft. Joby's a popular example, but there's a Lilium from Germany. There's Archer here in the United States, and a litany of others. There's over 250 different OEMs. But this is pretty exciting, because they have all these different designs, and they're all electric aircraft. But the business model hasn't been proved out, because it's just a market that's waiting to develop. So I think that will be exciting from an aerospace, just an aerospace at large standpoint. And again, there's definitely a role for 3D printed parts. I had some conversations last week at Formnext with various machine builders that have printed parts for some of these companies. And part of that is being used for prototyping. But as you know, that's the real challenge for us, our industry, is to move beyond just prototyping and into production, and in particular serialized production. And that comes back to the design flexibility and designing for additive and making complex parts that you couldn't necessarily machine, for example. So so I guess what I would say for this next year, AM, I don't know if there's going to be any major changes. I think it's exciting to see it as the TRL continues to increase and the technology matures. It's still a bit of the Wild West, I would argue, at least from an aerospace standpoint, but people in other industries probably think it's not moving fast enough.
Fantastic. Well, thank you for your time, sharing your perspective, and look forward to seeing you in the coming weeks and trade shows and in the new year for sure.
Yeah. Thanks, Mike. Really was a pleasure. And I compliment you for doing what you're doing to put the word out there and to help promote this technology, especially for young aspiring engineers. There's a bit of a renaissance of sorts here in the United States for manufacturing. We need that. That's really at the basis and the heart of a strong economy. So thanks for helping to promote this technology.